Welcome to topic 3 of module 1. In this topic, we will be discussing or reading about a very important thing, and that is the machine learning methods that are used in different information security domains. Primarily, there are two categories of machine learning algorithms. So we have the pattern recognition and we have the anomaly detection. And through this topic, we want to clarify the exact difference that where we have to apply the pattern recognition machine learning algorithms or where we have to look for the anomaly detection. In the pattern recognition, what we do is that first of all, we discover as an expert, as a security expert, we discover the explicit or very obvious and latent characteristics that are hidden in the data. That is actually like finding the characteristics in the data. That is the responsibility of the security expert. Why I'm saying this? Because if you are a data scientist but you are not a security expert, so you cannot actually look into the data. You have to be an expert, for example, in the network traffic analysis. You have to be an expert in the web application firewall because you know that what are the most important features. Another important step that can be done at this point is that both security expert and data scientist, they both sit together as well. But because this course is designed for security experts that want to do the machine learning, so as a security expert, you are the primary person that you need to discover those characteristics. You have the knowledge that you already have, you have to put on the paper. The second thing is that once you have those characteristics and we distill them into a set of features, actually, we use these features to teach an algorithm to recognize other forms of the data that exhibit the same set of characteristics or features. So what we do is that we teach an algorithm with the help of this thing that it has to be we teach an algorithm that these are the set of features that you need to learn, and then you have to look for these set of features in the future data. Patterns extracted through pattern recognition must be strictly derived from the observed data used to train the algorithm. So application of pattern recognition are, for example, spam detection. We will see in the spam detection that spam detection clearly talk about the talk about teaching an algorithm that what is a spam and what is not a spam based on different characteristics. So we can have a word count as well. We can have, for example, the stopping words as well that commonly appears in the spams, right? That can be the case. Similarly, malware detection, where we actually tell that, for example, if this is the sequence of steps, then this is most probably a malicious file. And then the botnet detection as well, for example, on the website, when we see a specific pattern, right? So we say this thing that this most probably is the pattern that is followed by a botnet and not a human. On the other hand, anomaly detection is an approach which works on knowledge discovery. So anomaly detection try to approach the knowledge discovery part like we instead of learning the specific patterns that exist within a subset of the data, what we do is that we tell the machine that this is the normal behavior, for example, and then ask the machine to identify the abnormal behavior. Now, the abnormal behavior can have infinite set of patterns that are not actually recognized by the machine. So, process of recognizing a set of normal patterns and differentiating it from a set of abnormal patterns. It can be vice versa. So we can learn the machine about abnormal patterns as well and ask the machine to identify the normal pattern. But the good practice is that because the normal one is less and also it is more obvious to the security expert as well. So we teach the machine about the normal pattern, and then we ask the machine about the abnormal patterns. Another thing that I actually stated in the previous slide as well. So the anomalous of the abnormal patterns can have infinite number of patterns as well. So you can have the pattern recognition in the anomaly detection as well. The applications of anomaly detection are network outlier detection. So you have a traffic and you are doing a network traffic analysis. So outlier detection means that, for example, if a port surfaced in the network, all of a sudden that was actually not seen before. That is a network outlier detection. Right, we have a malicious URL detection as well. So we have the URLs created with us, and then or we have a repository, and all of a sudden we see a URL which we have not seen before or which is suspicious, and because we established a set of normality behavior in the URLs, and then we ask the machine to identify the abnormal patterns for us in the malicious URL. So for example, in the phishing domain, we can have this malicious URL detection through anomaly detection as well. Now, one thing, I mean, we take an example because in this module we will be talking about, or we are talking about the spam detection in detail in order to understand the machine learning algorithm. So we look at the spam detection problem, which is solved by both pattern recognition and anomaly detection. So we try to establish that which one is better. Spam detection as a pattern recognition problem. Spam has a largely predictable set of characteristics we have seen. An algorithm can be trained to recognize those characteristics as a pattern by which to classify the emails. Now, spam detection as an anomaly detection problem. So we derive a set of features that describe the normal traffic, email traffic I mean, well enough to treat the significant deviation from this normality as a spam. Now, we can model the same problem of spam detection through anomaly detection as well as through pattern recognition. However, when we see spam detection might not be suitable for the anomaly detection paradigm. What is the reason? The reason is that it is easier to find similarities between spam messages than within the broad set of email traffic. So what we recognize is that when we have the pattern recognition on the spam fighting use case, it is more successful than the anomaly detection. We we also try to generalize the notion of pattern recognition and anomaly detection. So we say that whenever the threat model is well known in the security, we apply pattern recognition. And the cases where the anomaly detection is the answer, we have the network outlier detection, we have the URL detection. So we have a very small set available to us as a normal behavior, and then we ask the machine to identify as the abnormal behavior. I've already described the network outlier detection. So for example, we can have a network outlier detection on the flows as well, the net flows. So we give the machine the normal flows, and then we ask it to have identified the sequence of flows that are abnormal. And also any malicious network activity that does not manage to masquerade well by mimicking normal traffic will be caught by an outlier anomaly detection algorithm. Access control is a very predominant domain in computer security, where we have a set of policies which governs the ability of the system users to access certain pieces of information. So what we do is that we have a frequently used access control policies to protect sensitive information from unnecessary exposure. And by the way, this is the first line of defense as well against breaches and information theft. So we have a set of policies, we have a set of roles, we have users actually. So application of pattern recognition and access control, what we do is that we infer information access pattern for certain users or role in an organization. So we see this thing that a user actually log in at 9 a.m. and log out at 5 p.m. and all of a sudden we get an anomalous pattern that the user is logged in from some unidentified location, right? And for example, in the evening or in the midnight. So that is a kind of anomalous pattern for us. So we will engage an alert if we came across such an unconventional pattern. Thank you very much, and I see you in the next topic of module 1. Thank you.